what do we got here? We get the money problems. In 3 years, investment increases from $400 to $567. Determine the effective monthly interest rate. The hint there is a formula. Determine the yearly rate. Another hint, the monthly rate is not the yearly rate of 12. For a yearly rate of 12%, we'll take the 12th root of 1.12. That's just a hint on how you do this. A big part of this section is actually trying to figure out how to manipulate things to get other things. So the formula's right here. I think with next year's group, I'm going to make it pretty simple. If your first step isn't to write down the formula, no credit. Now, anyways, I want to know the effective monthly rate. I'm going to start off with T in years. All right, why not? So 400 becomes 567. In 3 years. Cool, cubed. I'm going to divide out the 400. So 567 over 400. Notice I hadn't hit buttons in a calculator yet. I'm just not going to. You can express that as a decimal if you want, but I'm not going to. And now what I'm going to do is I'm going to raise both sides to the 1/3 power because that's the opposite of 3ing it. 567 over 400, rooftop to the 1/3 power must equal 1 plus r cubed, rooftopped to 1/3. On the right-hand side, I get this beautiful perfect cancellation because 3 and 1/3 cancel each other out. And the left-hand side is something I'm going to have to evaluate in the calculator. So I go push some buttons here. Even on my best day, I wouldn't be able to do this. 567 over 400. Rooftopped to the 1/3 power is a decimal about 1.1233. Double check that. Yeah, and then I'm going to subtract 1. I'm going to move that 1 over to subtraction. So R is about 0.1233 or 12.33% annually. There's a lot of different ways of getting the monthly rate. But since there are 12 months in a year, the growth factor of 1.1233 can be raised to the 1/12 power to get a monthly growth factor. So that's what I'm going to do. I'm not going to take the 12.33%. I'm going to take the entire decimal, raise it to the 1/12 power. And I get about 1.0097. So the monthly growth factor is equal to 1.0097, which means the monthly rate is 0.0097 or 0.97%. So there's everything for 1. Moving on to 6. Bob invests $1,500 into a savings account that pays 5.95% interest compounded daily. How long will it take for the investment to double? And I gave you the layout here. Now that's the thing. His principal is $1,500. If it doubles, which by the way is A sub t, it's going to be $3,000. And I just want to know how long it takes to double. So 3,000 equals 1,500. 1 plus the rate is 0.0595. Compounded daily, 365 days in a year. And that gets rooftopped to 365 because it's NT, and I don't have a clue what T is, so just T. That's what I know. What I'm going to do is I'm going to divide out the 1500. I'll have 2 equals that big old funky looking thing. And the technique now is to ln both sides. ln of 2 is equal to ln of this big thing. I wish you guys were smart enough for me to skip steps sometimes. That probably didn't sound too nice, but that's the truth. Natural log of 2, exponents out to the front, 365t times the natural log of that ugly looking thing right there. Now there's 2 steps, there's one big step here. I have 365 times t and I have the natural log of this times t, so I'm going to divide them out. And my final answer, typed anyways, looks like this. That's t. Ugh, hideous looking, isn't it? What we got here? We got natural log of 2, sitting pretty over. Master set of parentheses. 365 natural log is 1.0595 over 365. Close, close, enter. Teeny tiny there. Something wrong. I wonder what I did wrong. Oh, I see it. Phooey. Supposed to be a plus symbol there, isn't there? That looks better. It's about 11.65 years. Seems reasonable. 6% interest. Most people's experience with interest is not growing money, it's borrowing money. That's the sad fact, you know. Don't be afraid to borrow money. I borrow money every single year, and it does cost me probably $1,000 to $2,000 in interest. It does cost me to borrow money. But when I borrow money, I'm usually borrowing it to make money. It's okay to borrow money to make money. That's not always true. Sometimes I buy myself toys and they don't make me any money. An investment will compound interest quarterly over the course of 6 years and double the initial amount investment. What yearly rate is it paying? We can do the yearly rate pretty quick. Yearly rate's pretty quick. It's kind of the same thing we just did. You just have to figure out your principal and everything like that. So your principal is something small like $1, and after some time it becomes 2 because it doubles. And we'll just say 2 equals 1 plus r over n. Talks about being compounded quarterly. It's going to take 6 years, so the exponent is going to be 4 times 6. This isn't that bad. We end up with 2 equals 1 plus r over 4 to the 24th power. If I can type. What we're going to do is we're going to raise both sides to the 1/24th power because that is the reciprocal. And I'm going to do everything on paper real quick. So 2 to the 1/24th. You can go ahead and figure that out in the calculator if you want to. Minus 1 equals r over 4. Took away 1 from both sides, subtract 1. Next step would be to multiply by 4. And I end up with this funny looking thing. 4 times 2 to the 1/24th minus 1 is my yearly rate. All right. So let's see what that is. 4 parentheses 2 rooftopped to the 1/24th power. Take away a 1. Gives me a yearly rate of about, that's pretty impressive, 0.1172. 0.1172. That's the yearly rate. The monthly rate would be where we take the 1.1172 and we raise it to the 1/12th power. So let me add the 1 back, raise it to the 1/12th power. Notice I just kept everything in the calculator. I get about 1.0093. If I take away the 1, I get 0.0093. I never even wrote down the yearly rate, did I? 0.1172. 7.72%. If I subtract the 1, I get 0.0093, which is going to be 0.93%. I can type. There we go, because we shift the decimal 2 positions. Daily interest rate is going to be just like I did the third part, or the second part. I'm just going to use an exponent of 1/365. Because we just assume there's 365 days in a year. We don't worry about leap year. So notice I'm using a calculator. I got 1.000337. If I shift that decimal 2 positions to the right, I get, and I take away the 1. I keep forgetting to do that. Wish I had more energy for y'all right now. I just don't have it. Y'all have sucked me dry. Move that decimal 2 positions right, 0.03. Or, sorry, move it 2 positions right, 0.03%. That's the daily rate. Thankfully, I'm about done with this video. There's only 3 more questions to go. Simplify cubic root. Now, you are expected to know the cubic root of -27. 100%. I don't know how to explain this any better, but I know that a -3 cubed is -27. So the cubic root of that is -3. 3 enters 8 2 times with a remainder of twice. It entered twice, so x squared out front. And inside this radical, I'm going to have 2x squareds left. 3 enters 6 twice, no remainder. Let me erase this. I don't like the way I'm writing this. So anyways, the cubic root of -27 is -3. You're going to have a funky looking radical left. 3 enters 8 twice, x squared out front. 2 remain. 3 enters 6 twice, remainder of 0. Now working on the bottom, I'm sitting over z to the 4th. 3 enters 4 1 time with 1 thing remaining. The real question is how far should we clean this up? That's the real question. And this is the part that kids hate and they just can't get. I mean, half of y'all can't do square root simplification. Anyways, it needs to be cleaned up. And there's nothing I can do about this. It is what it is. What I'm going to do is I'm going to focus on this funky looking radical. Cubic root of x squared. And let me erase that and make it look better. That is the cubic root of x squared sitting over the cubic root of z. And what I want is I want it to become something I can take the cubic root of z cubed with, because that would just be z. So what I'm going to do is I'm multiply the top and bottom by the cubic root of z squared. So cubic root of x squared times cubic root of z squared is cubic root x squared z squared. I've already done the multiplication down low. Z times z squared is z cubed. And I get that funky looking thing up top. So that's a deal because somebody said no radicals in the denominator. Negative 3x squared y squared over a z times what that cleaned up to. The cubic root of x squared z squared also over z. And then I can multiply these together. So negative 3x squared y squared cubic roots x squared z sitting pretty over z squared. Kind of interesting in a way. All right, 28. Solve the logarithmic equation. I wish there was an easier way to do this, but there's not. I know that I condense addition through multiplication. So the left-hand side becomes a single log base 5 of 2 times x minus 3. The right-hand side, that 2 gets moved up front, becomes log base 5 of 16, because 4 squared is 16. Now, I have a property that says if log base b of x equal to log base b of y, x equals y. So this stuff right here, which is 2x minus 6, must equal 16. I add 6, 2x is 22, I divide by 2, and x is 11. Easy peasy, Japanesey, even for somebody who's tired as I am. And here's a good ELC practice question. It doesn't quite meet the standards in Tennessee, but it's pretty close. Tennessee standards actually don't involve imaginary numbers anymore. But anyways, let's do some factoring. Let's look at x squared plus 25. What you might have to do is just kind of look at your answer choices. X squared minus 5ix plus 5ix minus 25i squared. And we know I squared is negative 1. The inside cancels, that becomes plus 25. So, we're supposed to draw a line, right? I'm just going to write x squared plus 25 in here. All right. Now, they have one of these a little different than the way I've taught it. And they have some that are really close. Like, let's look at 4x squared minus 16. The default thing you should do is pull a 4. And you'd be tempted to put a little check mark there, but no, 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 no. They have the word completely. They don't say partially. X squared minus 4 factors as x minus 2x plus 2, because negative 2 times negative 2 is negative 4, now minus 2x plus 2x, no x times x squared. So the complete factorization for 4x squared minus 16 was the top one, about being complete. So I've taken care of that one, I've taken care of that one. I've got this one, that one should be the easy peasy one. It's obviously got to be the guy right there. But if you were to check it, you'd get 6x squared minus 10x plus 3x minus 5, and that's it, because negative 10 and 3. Oh, it's not this one, is it? No, it's this one. 6x squared plus 10x minus 3x. That's it right there. So this is 6x squared plus 7x minus 5. This would be the idiot answer to that one. Like this is the one that you're not supposed to pick. One in 4 students pick it. It's this one. That's the one it is. And I'll explain why. I don't teach this in Tennessee. It's actually not part of it. We kind of do and we kind of don't. We teach you how to do the quadratic formula in the second part. But x squared minus 27, a is x, b is 3. Factors using the pattern a cubed minus b cubed. Factors is x minus 3, x squared, plus because there's a plus, 3 times x, plus because there's a plus, 9. This guy right here is hit with a QF. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. We get negative 3 plus or minus square root. This is 9 minus 36, which is negative 25. Both pieces over a 2. So negative 3 halves plus or minus 5i over 2. And I apparently have done something wrong. What did I do wrong? I'm not sure. Oh, yeah. It's right there. That's root negative 27. Bad Milbrath. Now, root negative 27 is going to be an imaginary root of 9 times 3, which is 3i root 3. So there we go. Negative 3 halves plus or minus 3i root 3 all over 2. And what they've done is they've entered the parentheses and they've changed the sign. Here we have a minus and a minus became a plus and a plus. Here we have a minus and a plus became a plus and a minus. So that's why that's x cubed minus 27. And I believe that is all of the homework that I decided to do from that section, and I hope it made some sense. The goal is growth here. If you're a 1, become a 2 become a 3 become a 4. If you're the one kid who's supposed to be a 4, stay a 4.